let's see what's going on. All right, welcome. Looks like we have four people, one of which is my cell phone. So I'm guessing Mr. Drews is the other one. I realize we're going a little earlier than normal, so I suppose I'm speaking mostly to people who are going to watch this later. We'd prefer to go on a more regular schedule, but it's just not possible. But that's fine. Uh, if you have a question, you can always submit it from the Google form, and we are happy to answer them. And or you can get your question answered in chat live. So that's something to think about. All right, so today we are going to talk about the um, create task. Let me give Mr. Druzy access to this. And there we go. Okay, so we have already spoken about the explore task, and here we go, explore task. We've given you a folder with all the documents in one place, template, instructions, rubric, and some examples, and also we did a stream dedicated to that topic that you can watch later, and we're going to do the same thing for the create task. Okay, so right now we already have we'll start the folder with the written response, although let's go ahead. Mr. Drucy, do you want to start sliding stuff onto a new announcement or into this folder? You're on this folder, right? Great. Okay, so just a little peek behind the curtain. The way code.org has this set up is, let's take a look at the entire year. We have, of course, our units 1 through 4, then the explore task, and then 5, which we just did. But we are sort of grouping this explore task, which is set up sort of like its own unit, with the create task. And unfortunately, we can only give you access to one at a time, which doesn't make much sense to me, but it is the way it is. So let's take a look at this unit. We will give you access to this on Monday, which, by the way, the deadline for Unit 5 is going to be Sunday night, which is deadline for Unit 5 L15 through L17, which is all of the remaining units for Unit 5. And then we will open create task unit in code. Okay, so this unit that you won't have access to until Monday is just sort of a framework. You do not need this information to complete it. It's really just sort of I would say distilled, except there's a ton of stuff, here, so it's not exactly simplified. Can you hold on? I'll be right. Okay, so I don't know if you could hear that, but that was the reason why we can't have streams at the regular time. Okay, so in this unit, there are all the documents that you can get from College Board, but they're just sort of all in one place. And I don't think the College Board is a um, very well designed page as far as trying to find specific things, which is why we are going to do the distilling and get you a folder similar to the explore task, where we have the most important documents here in the front, the instructions of the rubric and the template. So we'll do that for create task. Right now we just have the template set up, and it's not even a thing yet. Let's just go and do that right now. Create task, and let's here and
We already have the create task that's on there. I was putting together, and we got to chop up the PDF document and stuff.
okay. I was just gonna
Go for
make
it.
make a post, but that's okay. Um, we'll have that done by the time that you guys need to get to it. So let's, yeah, okay, so let's go back to the code version. We have the instructions. That's going to be the main document. But is this the instructions for all of the tasks? Um, yeah, so this is the same instructions. This has the directions for create as well as explore. Um, Computate, yeah. So it's the same list of instructions. It doesn't have the rubric in the same form that I'd like to see it, and I actually am having trouble finding the 2-page or 3-page, the 8-row rubric for create task. Okay, so create task has the same format of rubric where it's 8 rows where you get either 1 point or 0 point for that row, and your grade is out of 8, and there's no half credit for each row. There is only credit for that row, but we need to find that document. I have it from past years, but I don't want to use those because, here we go, because they may have changed, so I want to make sure that we get the correct one. Let's just go ahead and put this in here, and then let's do a little we can rename this as we go. Okay, so this is the rubric that we will be working from for the create task. We will talk about the 2 main concepts other than no, I don't want to do that. Other than the fact that it has to be a program. So let's start with that. The idea is you are creating a program from scratch. It needs to do something. It needs to work. Okay? It does not need to be amazing, but it needs to function. And you are going to write out the code for it. You are going to record or capture a video of it working. If you don't have a way of capturing video on your computer or Chromebook, I think it would be acceptable, especially in our current circumstances of having a video, like a camera cell phone video of your program working on
I
a.
think there are also plugins you can get on Google Chrome that will record your screen. We can look into, we can do like a Q&A session on how to get those to work as well if we want for the future, but I think
Okay.
those are available.
Okay. So you'll be writing your program. The 3 things that you're going to submit, one is a no more than, I guess no more than 1 minute. I thought it was 30 seconds, but no more than 1 minute video of it working. It doesn't have to show every feature, and if one of your features is broken, I would say don't demonstrate that it's broken, but that's up to you. You're mostly just demonstrating that it functions, and you have things updating and that sort of thing. So that's the first thing you're going to submit. The second thing you're going to submit is a the written response, which your written response is similar to the written response for the Explore task. I'm not crazy about this version. Yeah. Okay, so this is similar to the template that's already out there, where there are 2A, 2B. Let's go down to D or E. D, and that's it. So 4 responses that have to do with your program. Just like the Explore test, the first 2 are super simple. Just the first one is, what is it? What does it do? Okay, needs to be about 150 words. The second one is talk about how you made it, approximately 200 words. Then we get into the 2 main concepts. Okay, the 2 main concepts, which we haven't really specifically talked about, except in a couple of the AP performance task, short answer, writing prompts, are algorithms and abstractions. Okay, we've definitely talked about abstractions. Abstractions are things that simplify and make more complex things easier to use. Okay, so you think about, remember we had, like, one of the first programming things we did was where you had to write a program that drew like a snowflake shape, where the first thing you did was you wrote a function that made the turtle go out and back like 3 times. Then you wrote a function that used that function to make like one of the T's or crosses. Then you wrote a function that used that function to make the entire shape. Okay, it's about levels and simplification so that it is easier, it simplifies things. One of the ways to do that is functions that use other functions, and also functions that use parameters. Having a function that takes multiple parameters makes that a more versatile tool, and it allows simplification of whatever concept you're trying to write about. So that is something to think about. The other concept, algorithm. Algorithm is the idea of using multiple mathematical and logical concepts. Okay, some sort of calculation. The orange bars, the comparison operators. If something is greater than or equal to this, do that, and so on, and any sort of arithmetic, mathematics, division, that sort of thing. Algorithm is just a complex equation that you would use to solve some programming problem. All right, so let's proved clicker game. So this one looks like the starting point is the clicker game from Unit 3. That might have been very early in Unit 5. But I highly recommend not handing in something to the College Board that is directly a project that we have done. They will see a lot of them, and that is not good for your prospects. I even more strongly recommend not handing that in to me. Just complete plagiarism and copying and submitting something from that we did as part of a project in class is the same as not handing anything in. It's not your work. So there's that. Just like with the explore task, where the most or the first step and possibly the most important step was coming up with a topic that you could use that would fulfill all the requirements. That is also a great strategy for the create task. Think about the fact that you do need abstraction or an example of abstraction, and you do need an example of an algorithm, something that calculates something else, and make sure you are incorporating that into your design. So you're sort of working backwards from the goal, but that is a good strategy definitely for this. Okay, so I guess let's go through the or the rubric and see if
There's
there's anything
a
that I forget.
there's a written response template in the folder now for you.
In the create task, this one. This was already here, but
I think we're in different folders.
huh, you're not in the one called create task. Yes, no, maybe so.
I am, but that's different than what I have. I have 4 things in mind.
Okay. Well, regardless, I would like to find or create a written response. This response is definitely downloaded from the site, and I think it's kind of sloppy. Or it's, however Google Docs does a poor job of implementing.
Yeah, I have a good one. Go back to your drive real quick.
There we go.
There it is.
Okay, yeah, this is much better, especially with the prompts. Hello. With the prompts that go along with each one. So you would definitely be making your own copy of the document and using this one. Sweet. And, okay, so I forgot. The 3 things that you are submitting: the video, the written response, and the third thing is the code print thing that we did a while back, which was the Baker Frankie site that has nope. All right, so I'm all over the place. The create task unit, so to speak, that will open up on Monday does have all of these documents and some examples that we will put into this folder today so that you can get to them. It also has a place, it has some planning tools that I don't think are going to be assessments, but are there certainly for your benefit. And the third lesson is gives you a place to complete it. The lesson 3 bubble 2 is a place to work on it, but I highly recommend just opening up, I think you can get it from just My Projects, and creating a app lab. I think if you just Google app lab, it'll come to this, and it will give you, this is the full-on open version of app lab that has every single block, and here there's no way it could be ever hidden behind the unit. If the unit ever gets switched to, I would like at some point to switch to the explore task unit, but here if you do all your work in the app lab you can it just access it regardless of whether or not you're in the class or in the future, and it is a good place that just sort of is like a standalone um, location to work on stuff.
And just a heads up, I went ahead and put the create task folder. I made that available in Google Classroom. So if people want to join in, it's not completed yet, but we have some things going in. It's kind of like a live working document. So you can see all 4 of the things we're working on.
Good. So yes, if you're watching, if you're one of the 5 concurrent viewers, I'm guessing Mr. DeRusi is one, I know I'm one. So if you're one of the select few that are watching it live, you could look at them now, and if you're watching it as a VOD, you can, it will still be there, so there's that. And, what was I doing? Oh yeah, the third thing, let's get back to the third thing. So we have the video, the written response template. Well, the written response is, oh, I love that. This is 150 words. I love that. And the code print thing that pretty sure is linked here. We'll definitely link it in the folder or in that announcement that has the folder, and we'll have a link directly to this this stream. I think it will probably be linked in one of these documents. I'm surprised it doesn't have a direct link. Oh, that's not what I was looking for. Yeah. So, excuse me, the code print thing is a, I suppose, proprietary tool that belongs to code or belongs to the guy who wrote it, Baker. And Mr. DeRusi, have you seen it recently where the link is? I mean, I can just Google it. Let's go ahead.
I have not. No, and I think you turned in a project this way earlier in the year. I didn't do that with my group of kids in the first half of the year.
Okay.
So this the code print is kind of new to them, but it's not that complex.
No, yeah. Okay. So this is the tool that you're going to use to hand in your full code, which should be allowed to edit this. Let's add a link. Okay, so this tool for the code print, is there a way to edit this title? No. Okay, so this site, what you're going to do is copy and paste your full code project. Let me see if I can find, this is an earlier one that is definitely not a full project, but you're going to switch it to text, and this is after you're done with your project. Copy this into this area, and it will show up down here, and you'll use rectangles and ovals to highlight portions of your code that represent the examples that you are providing for the different one for abstraction and one for the algorithm, which makes it super easy. I don't know how students not using code.org would accomplish that. I suppose in like Photoshop or something like that. Keep that open. same thing as that. Written response. We don't need that one anymore. Is that still in there? Should we just get rid of this one? Oh,
I already did.
Thank you. Way ahead of me. Just refresh. And remix. These are examples. We can go over examples later. Again, examples. Okay, so here's the rubric, and this is more of the instructions. Okay. So, man, I'm all over the place. So I guess let's just go back to the rubric. Take a look at it. Why am I not able to? Okay, there we go. All right, so again, working backwards, generally a good idea. We're going to look at the rubric, and hopefully that will spark some interest or some ideas. Again, think about some good points or strategies for coming up with a project that works. Is think about, you're going to need some sort of algorithm, something that calculates something. You could use a return function. That probably be a good example of abstraction, but the algorithm is going to need to take pretty much a function that takes inputs and calculates something. So you're going to need some aspect, some feature of your program to do that. But let's start with the first things. Okay. So develop a program. Row 1 for this is you hand in a video, and the written response identifies the program and what it's attempting to do. This lines up with the first one that identifies the programming language. The programming language that you're using is AppLab, technically. I believe you could write JavaScript as the programming language, and it still technically would be correct. But when we get to handing in the actual digital portfolio, the option will be AppLab. And for this prompt, you're identifying the purpose of your program and explains what the video does. And that's the same thing, another rehashed way of saying row 1. Do not award a video if any one of the following is true. Okay, so you'd lose the point for row 1 if you don't hand in a video. You'd lose the point if your video doesn't show the features that you're talking about, and which you could have a super complex program that does lots of things, but if your video doesn't show, if you don't show the thing that you are using as examples or explaining, it's essentially a different video. And do not get the point if your video does not illustrate the running of the feature. Yeah, so in other words, it needs to work. Okay, purpose means the intended goal of the objective or program, and function means how the program works. Again, these are just, you earn a point if this, you don't earn a point if not this. So yeah, it's a lot of the same stuff written multiple ways. Okay, so row 1, the program has to work. Easy. Row 2, develop a program with a purpose. Okay, this is about your second response. Does it outline the steps of incremental process or development process to create the program? You are just going to talk, or rather write, about how you made the program, and focus on you need to name at least 2 parts that you so you can't just say the process I used was making the program. That's not good enough. You need to talk about at least 2 iterations, 2 points. I would use more points just to make sure you've got it covered. And difficulties slash opportunities, these are just sort of design challenges. Clearly indicate, I think that works. Describe the difficulties. These are just the programming challenges that you faced as you were going through this. And you are doing this, you are not collaborating. There is an option for collaborating for like the first portion of the design process, like the idea stage before you get to the programming stage. But I would say don't collaborate at all. That completely mitigates any sort of issue with the grading person, the grader, taking it as plagiarism. They use the term plagiarism, or I guess I don't know if they use it this way, but the idea of working with somebody is against the rules for the second half of the process. But just to make sure there's no issues with whether or not you've crossed the line, I would say do not collaborate. And so you will say that it is independent here, and at least one of the points was referred to independent program. Okay, so as long as you are doing 2 points, you're talking about at least 2 points in the design process, like coming up with the, not, I wouldn't say coming up with an idea maybe would be 1 point, and figuring out a way to do something else. I don't know. I don't want to give you too many examples because that will sort of box in your creativity. So because you are going to do it independently, you don't have to worry about one of the 2 points that you talk about being about the independent portion of your design process. So that sort of takes care of itself. Okay, and must not exceed 200 words. Let's go back here. We're still on row 2. Do not award a point if any of the following is true. The response only includes the process for determining the program idea and does not address the development process. Okay, so from the way I read this, one of the points can be, one of the 2 steps or iterations you can use is coming up with the idea. But you do need to, one of the 2 needs to be about creating the program. And if you don't talk about iterative development, iterative just means a step-by-step procedure of development. If it does not refine the refinement and revision are not connected to feedback, testing, or reflection. Okay, so this is an important thing that's not really referenced anywhere else. You need to talk about how your iterative process is about testing or reflection, meaning like as you're developing the program, something didn't work and you overcame that by doing this, or after using it, I found that this was a better way of doing something. And the response only describes the development at 2. So here, this reads as there needs to be at least 3. But this reads focusing on 2. Yeah, so I don't know if this is a typo of only describes development at 1 specific time, and it should say 1 there, or at least 2. I would use 3 specific steps in the design of your program to talk about for the written response, just to make sure that there's no confusion. Okay, development processes are iterative and cyclical in nature and require students to reflect and improve. reflection, revision, testing, and refining. The improvements based on feedback. Okay, so reflection, revision, testing, and refining, and feedback. I don't know, it sounds sort of sketchy that they want it to be independently developed, but how do you get feedback when you're designing something independently? I suppose they could have they it is reasonable to have you or I think it's reasonable to have you use uh, QA testing, quality assurance testing, that meaning let somebody else use the program and see if they can break it or if it does break. That is a very common standard practice for any sort of development. So I don't know how they can expect feedback without somebody else seeing the program before it's done. Now that's different than having somebody else see the code and solve problems for you. That's different um, than feedback, but this needs to be all discussed in that second written response to get the point for this row. And the incremental and iterative development process does not need to be a formal method. Okay, so you don't absolutely have to refer to our abstraction was the bottom up, most complex thing, and then simplifying it. So that's not required. So it doesn't have to be your example of abstraction. It can just be sort of the timeline of you developing. Okay, so row 3. This also has to do with the second response, the second written response. And if you notice, the first one is 2A, and that's because the part of the assessment that is labeled 1 is the video. So 2 is the written response, so that's 2A through 2D, and that's the same as for the explore test, where the part of the assessment that is 1 is your computational artifact, and the written response is 2A and through 2E for where E is the sources that you used. So here we're still on 2B. Specifically identifies at least 2. This seems kind of repetitive. I suppose this is just a more specific one where if you do everything here for row 3, you will have done everything for row 2. And I think it's just a way of striating the points so that they can make the second written response worth 2 points. So it's a lot of the same thing, coming up with 2 difficulties or opportunities that you resolved. I would say the opportunities are specifically about the programming portion. How did this work, or this didn't work at the beginning, and this is the way that I fixed it. That's essentially what that is. But again, it says response only describes at 2 points. I would make sure you are keeping track of 3 points. And this is the sort of thing that you can reflect upon after you're done. You could keep track of it as you go, but I would say definitely possible to do after you're done with the program, but something to keep in mind regardless. Again, multiple, only 1, you don't get the point. Yeah, so you're going to pick out 3 points, and well, this is difficulties as opposed to specific steps. I suppose one of your 3 parts, 3 specific points that you talk about can be coming up with the idea, And then you need at least two specific points in your development process that have to do with like programming difficulties or opportunities, um, and talk about how you solve them. All right, here we go. This is the meat of it, the algorithms. This is where you are going to be graded on the portion of code that you put in that is either going to be an example of an algorithm or an example of an abstraction, and they are going to grade you on whether or not it is an example of abstraction and or whether or not it's an example of algorithm, and they are not going to go through your entire code and say, well, this actually is an example of abstraction, but the part you highlighted was this one, so they're going to get the point anyway. No, they are only going to look at the portion that you highlight, and let's make sure we get it clear. Does it say somewhere in here? It says which one gets an oval and which one gets a rectangle. I want to be clear of that first. Mr. DeRusso, do you see the point where
For the
it's probably in the
oval,
instructions?
yeah, 2C capture and paste program segment that implements an algorithm is marked with an oval.
Okay, so algorithm is oval, which algorithm is the complex um, um, equation, and so this is another program that will go through. All right, so this would be an example of an algorithm, and let's see what some good ideas of what an algorithm would look like before we. Okay, this is calc first tie, and okay, so any function that has a ton of the orange blocks is probably a good example of an algorithm, because these are the math concepts, the equivalence operator, and the mathematic or arithmetic operators that are just, addition and so on. This would be a good example of abstraction as far as I'm concerned, and that would be what you highlight with a rectangle. You can play around with this. You have the opportunity to use up to 3 different rectangles, and they're all different elements that if you want to clear one, you switch back, and that would clear the first one, that would clear the second one. Anyway, you are going to highlight a portion here that is your example of an algorithm, and you're going to copy that same bit of code from either from here, which, let's see here, let's go like this. I'm going to have to undo this or just make a copy so I don't break it. So your example of algorithm is going to be here, and there I just copied the function from code. You could also find, I would say, you'd have to like crop it, and I wouldn't worry about that. I would just put in the actual code, and this is where you're going to talk about this portion of code. This portion of code needs to be your example of abstraction that you talk about. It also needs to be the same one that you highlight in your code print. So, and that's what the rubric is based on. It's based on only the grading person is only going to look at that portion of code. And I'm guessing, I wish they had posted like what their specific grading criteria is. Now, this obviously is specific grading criteria, but I have to imagine they somewhere have a list like, does it use two or more examples of um, arithmetic and greater than, and like that's just what they look at, and it's either yes or no. They wouldn't post something that's simplified because, and again, I'm just speculating that this document or concept exists, but I imagine that's the case. But you do need to make sure that you hit all the points for the rubric. This is the main document, is whether or not you're going to get these 8 points. So let's take a look at algorithm. Again, this I'm pretty sure is just like the row 3 and row 2, where row 3 was just sort of a more elaborate version of row 2 as a way of getting you sort of partial credit, but we're going to make sure we get all of them. So the first one is your selected piece of code an algorithm? And how they are going to describe that. Do not award a point if it only consists of a single instruction. Okay, algorithms are precise sequences of instructions for purposes that can be executed by a computer and are implemented using program language, sequencing, selection, or iteration. Let's read this and see if it clarifies itself as we go. Okay, do not award the point if it consists of, it probably should say only a single, because that could be read as any instruction, but we'll take it as only, if it only has a single instruction, and the code segment consists of, the algorithm is not included in the written response. Okay, so you need to make sure that your code segment is put in here. And the algorithm is not explicitly identified. The entire program is selected as an algorithm. Okay, so again, this is just whether or not you've chosen an algorithm from the from your code. Okay, row 5, you need to make sure your algorithm has mathematical or logical concepts. It needs to okay, so this is in the response. You have to explain what makes it an algorithm, and which I would use their language as a way of describing your algorithm, your piece of code. Make it easy for the grader to give you the point. That's what I would say. And describes what the selected algorithm does in relation. Okay, so you're saying what it does and why it's an algorithm to get the point for row 5. Let's read the repetitive stuff that maybe will clarify the algorithm being described. Utilize existing language. Can utilize existing language functionality or library calls. Meaning you don't have to completely reinvent code in order to work it. I think that is a yeah, so that's different than, we'll talk about abstraction in a second, but you can't use your event handlers as an abstraction. It needs to be sort of original stuff. But here, I'm curious what they are considering existing language or library calls for this. Like, I don't think you can count random number as one. Okay, so let's get to this point. Do not award a point if selected algorithm consists of a single instruction, so it needs to be more than one. Oh no, did we get through this one? It's not explicitly identified. Oh no, yeah, we did get through that one. The response, selected algorithm consists solely of library calls, so again, original stuff. It needs to be original. Needs to have some original stuff. I think it's allowed to have some existing like I suppose it could be in an event handler as a meaning that it doesn't have to be completely original. Although I don't know. Response only describe where are we? Selected algorithm consistently. Do not award a point if the selected algorithm does not include mathematical or logic. Okay, so you have to have some orange blocks or what become orange blocks after you switch it back to block mode if you're typing it out in text mode. And do not award a point if the response only describes what the selected algorithm does without explaining how it does it. Okay, it's pretty self-explanatory. You need to explain how it works, not just what it does. The response does not explicitly address the... Okay, so what it is, how it works, why it does it. Okay, we're starting to see a pattern here. Selected. So it needs to be the piece of code that... this piece of code needs to be this piece of code, and it needs to be what you talk about. Okay, pretty easy. I think that's a difficult mistake to mess up as long as you're paying attention. And the algorithm's not explicit. Okay, again, same thing. Pick out one chunk that counts as an algorithm. And mathematical include expression using arithmetic operators. Logical Boolean. Okay, so these are just arithmetic, addition, subtraction, multiplication, division, and these are the greater than, less than, equals, not equals. And iteration is repetition. Selection uses both a Boolean condition to determine which, or uses a Boolean condition to determine which of the two parts of an algorithm. Which of two parts of an algorithm? Do you understand this language, Mr. Neruzzi?
Which one specifically?
The one that I've
The
highlighted?
highlighted one?
Yeah.
Selection uses a Boolean condition to determine which of two parts of an algorithm is used.
That is some opaque language. I don't think that is explaining which of two parts of an algorithm. What does it say about two parts? That I don't think they're clarifying anything from last year's rubric. Okay. All right. Iteration is repetition of a part of an algorithm, and selection uses Boolean condition to determine which of two parts. That looks. This looks a lot like this one, so somebody's copying and pasting. It's kind of sloppy. Also, again, doesn't really make sense. Single instruction. Does that include? All right. Kind of unclear what they specifically are counting for this one, but I would say make sure that you have a bunch of blue and orange blocks, or the equivalent in texts. Those are going to be your ifs and your, if greater than or equal to, and so on. And so let's keep going. Row 6, still about algorithms. Select at least an algorithm that includes at least two or more algorithms. At least, I think we're going to need to go to the examples to see at least one of the included. Explain how one of the included algorithms functions independently. An algorithm that uses at least two or more algorithms. So I guess they're looking for complexity. Responses are still eligible to run this point, even if they don't include subparts. Well, how could they be subparts if... Let's go to examples. Let's find. They don't even provide an 8 out of 8. These I'm pretty sure are the same examples from the College Board website, or they have been in the past. Let's see here what this guy has to offer. Might as well open up this one as well. Oh, jeez. That's not what I'm looking for, but okay, so great. This one, 7 out of 8, did not earn the point for the one that we're looking for, and it's also super small, which again is not what we're looking for, but okay. I forgot which row is this. Row 2, row 3, row 4, row 6. Okay. To receive a point, at least 3 algorithms need to be defined and explained. Needs to include a reference to 2 other defined as included algorithms in the scoring notes. There's not an algorithm that is using at least 2. Okay, so we need 3 algorithms. One of the algorithms needs to use the other 2. But the 2 algorithms independently call what? While 3 algorithms show there's not an algorithm that is using at least 2 or more, the 2 algorithms independent. Oh, okay. So in the example of this one, 2 of them, it's 2 different algorithms that use a third rather than one that uses 2. I think they're looking for one that uses 2 as like, let's see if I have an example of an if-else that sits inside of a, so like, if, let me remix this one again, a remix. If this was broken up into, let's copy it to not break it. So this is an if, else if statement that, or if, else statement that it could be broken up. And it's unfortunate that in order to make your program fit the description of what they want, you may need to modify what already works in order to make it something else. So let's see if I can give you an example of this. Let's put an if statement here, and we'll put the main one here. So if the first thing happens, do this, else, and then put an if else inside of that. And then an else inside of that. And this was at the bottom. Okay, so here we have one algorithm, and I think this is what they're counting as it. The first algorithm is the if statement, where there is a if this is true, if this is true, do this. Otherwise, do this. Okay, and if it makes it to here, if it makes it to the second part of the primary one, it has now the option of checking for this, and if that's true, do this. Otherwise, do this. So there, the problem is, yeah, I think something like this would definitely count as an algorithm using 2 other algorithms. I don't know how this could be less than what they are expecting. But yeah, I would say add complexity even if it is not absolutely necessary, just to make sure you get that point. Where were we? Algorithms. Are we in the third one? Explains how one of the algorithms functions independently. How would one of these functions independently? I suppose this first algorithm, if this, do this, this works completely unrelated to this portion. So, but does it have to be one of the second, one of the lower? A lot of their language sounds kind of contradictory. Um, let's see if we can find an example that um, gets the point. This one doesn't get the point for row 6 either. Let's see what their explanation is. Row 6 is not clearly identified. The two included algorithms must be defined and explained. Let's see what their portion is. I use an algorithm. This is all the student response. When the event handler cat image was called, it would not.
I think there might be some typos in that. So from what I've kind of found with algorithms, I think it's looking for like an algorithm is made up of 3 basic blocks: sequencing, selection, and iteration. And then when it's referencing, if it's using like 2 parts, so the selection uses a Boolean condition to determine which of 2 parts of an algorithm is used. So is it asking if it's using sequencing, selection, like is it using 2 parts, like sequencing and selection or sequencing and iteration? Is that what it's asking for? Or are you obviously this is kind of like nitpicking and getting stuck on one part of this that I think might have a typo on it or some sort of lacking of an instruction.
Yeah. I think this, something that looks like this, would count as an algorithm that uses 2 other algorithms. Also, just the whole pile of orange blocks would be useful. That's frustrating. I don't know. I guess the takeaway is just use a bunch of orange blocks and blue blocks. That is disappointing. All right, so that's algorithm. Use orange blocks and the blue blocks that go with them. There you go. All right, abstraction. I think it's unfortunate that both these words start with A, especially if these words are new to you. Similar to the explore task where there's computing innovation and computational artifact. If you confuse those two, you might have some trouble. But here, abstraction, completely different concept than algorithm. Although I would avoid this, but I do think technically you could count your example of abstraction, of algorithm, as your example of abstraction, but I highly recommend against that. Again, just make it easy for the person, the grader, to get you those points. And let's see, where are we? Okay, abstraction, there's just 2 rows, 2 points that have to do with this. Let's see here if we can get a definition. Uses response that use existing abstractions to create new abstractions, such as creating a list, represent a collection, would earn this point. The response using an existing abstraction, such as variables, existing control structures, and event handlers. Okay, I do know that you cannot use this is for abstraction again, don't forget, you cannot use a event handler, meaning the yellow block, as your example of abstraction. But Yeah, I don't think you can use, well, you can use these throughout your program, and you will need to use these throughout your program. You really can't write a program that interacts. We did do the draw landscape thing that just all ran and drew your landscape right away. Uh, and that didn't have any event handlers because there were no events, there were no buttons, there was no clicks, that sort of thing. But so I'm saying I don't think you could write a program for this project that doesn't have event handlers. But we need to find an example that has a some sort of, I suppose it has to be a function that um, simplifies. Okay, the response is an existing. So yeah, you can't use event handlers. Um, it's not included. Okay, so you need to make sure it gets to the written response, and you need to talk about it and make sure it's the same thing that you. Okay. So let's just. This is kind of going a little long. How long are we right now? Hour 15. I did realize this was going to be a two-parter, um, especially if we want to go into more specific examples. So let's cut it off right there, and we'll jump in tomorrow, hopefully tomorrow, with the um, talking about abstraction. But again, do not forget, even if we don't stream tomorrow, which is a possibility, the um, even if we don't stream tomorrow, the um, explore task is still ongoing, and there is still the um, the three lessons at the end of Unit 5 that are the deadline. They're going to be locked off on Sunday night, technically early Monday, but don't count on any time on Monday because we need to open up the create task. Um, so maybe we should just count on that. I do think the schedule, my personal schedule for tomorrow, is not conducive to finding a time. Um, so, Mr. Drusi, are you all right with that? Do you think that's a good plan?
I'm good with whatever needs to get done.
Okay. So let's. We're not going to stream tomorrow. Um, no stream. Keep. Work. Finish. Unit 5. And keep on with explore task.
I think also now that the create task is posted, people are going to be able to access all the files and everything, and be able to look over it. It's a lot of information, so hopefully they can take the next couple days to look through it and digest it at their own speed. So then when we come in on Monday, they'll have questions and whatnot.
Yeah. Okay, so this is just part 1 today, and we will do part 2 on Monday. I will have a time um, posted probably tomorrow night when um, our other people have a idea of what their Monday schedule looks like. So that is the where we're going to wrap it for now. Okay, so it looks like a lot of the questions are being answered by Mr. Drusi as per usual, and let's wrap it up there. And I'll see you guys on Monday. Okay, adios.